is the inverse. So e to the x is the original function, it's exponential, and the inverse is the natural log of x. So the e to the x is in pink or red. The inverse is reflected across the line y equals x, and it is equal to the natural log of x. So e to the x and natural log of x are inverses of each other. When we go to do derivatives of these, which we love, we got to talk about some of the properties first. Now the properties are coming from pre-calc 1, and if it's been a while, that's okay. It's not a problem. We're going to go over them now. So we know that e raised to the natural log of x is equal to x. So that's one of the rules that we learned in pre-calc 1. Provided, of course, the x that I am looking for is greater than 0. And the reason that is because if I look at my graph here, I'm just going to go back up to my graph in pink. My graph in pink has a horizontal asymptote without a transformation at y equals 0. So none of my outputs will ever be negative. Unless I have a transformation, it'll never be negative. So if I raise e to the natural log of x, it will equal x, provided x is positive. Now, it also has to be positive because when I take the natural log of x, I'm going to come back up to the graph here again. As I take the natural log of x, you can see my domain starts at greater than 0. The values I'm going to put in the natural log are greater than 0. I can't take the natural log of a negative number. I can't take the natural log of 0. So the natural log of the e raised to the natural log of x is equal to x. X must be greater than 0. And the natural log of e raised to the x is equal to x, and that's true for all x. That's true for all x. So in this case, on this second one here, this particular case right here, I don't have any restriction on the x here. So if I asked you to find the natural log of e raised to the negative 3, it is negative 3. I have no restriction on that one. I do, however, have a restriction on this one because I can't take the natural log to begin with here, the natural log right here, of a negative number to begin with. I just can't. So it is restricted because I can't take the natural log of a negative number. Now e raised to a negative 3 is not a negative number, it's just a decimal number. It's less than 1. Okay? The other things that we get is y equals the natural log of x if and only if x is equal to e to the y. You may see this also as this. You may see e to the x is equal to y, and if and only if x is equal to the natural log of y. You may see it that way as well. In fact, when we start with pre-calc 1, that's the way that we see it, is we have x as our input, y as the output. Since the natural log is the inverse of that, I have the answer. I want to know what gave me that exponent, what exponent gave me that answer. The last part is, this is going to be true, is b to the x is equal to e raised to the natural log of x, the natural log of b to the x, which is the x just comes down out front as a multiplier. So these are the rules of exponents and logs, and I'll give you a refresher again on those log rules in a moment when we need them. So all these are all the things that we need to keep in mind. Any questions so far? Anything? Okay. I'll give you a couple of moments to write that down. So then we're going to just jump right into the derivative. So the derivative of e to the x is e to the x all day long. The proof's in your book. If you have nothing better to do tonight and you're like, man, I don't think I can get to sleep, you pull that book out and you read it. You read it like no other. You go to sleep. Actually, the proof isn't that bad. I just don't like to spend time in class to go through the proof. But if any of you is like, man, I really don't completely understand the proof because you tried to read it, come see me and we'll go through it. But it takes a lot of class time to go through the proof, so I don't do that anymore. I'd rather spend the class time doing examples. So the derivative of e to the x is e to the x all day long. And then the second part is, if you have e raised to some function, it's going to be e raised to that function, the derivative of that function. The way you may see this also is with u. So d du of e to the u is equal to e to the u prime. That's another way you might see it. So you're doing with the u substitution. Coming out of pre-calc 1, that is the most important thing you'll ever get is u substitution. U substitution is so terribly important. Now we're going to combine all of this stuff with what we've learned already. So the product rule, the chain rule, the quotient rule, which I hope never to ever do. We have also sine and cosine, so the derivatives of my functions as well as inverses. So this is like the last thing in which it'll wrap everything up. Okay? If I'm asked to find the derivatives of these, then I just go and do the derivatives. Which one of these would you like me to do? You all get to do the rest. You want me to do C? That's easy. I would have done D, but no, I'll do G. No, you all said C, so. G prime of x, or dy dx, or y prime, is equal to, I'm going to do the derivative of each one of these individually because what's happening here is there is addition or subtraction between them, so I don't have to worry about the product rule at all. I don't have to do the quotient rule. I don't even have to really do the chain rule much. So I'm going to do the derivative of the first one, and that's linear. So it is 3 over 2x. The derivative of x is just 1. So my first term is just going to be 3 over 2. My second one is 7 e to the x. Well, the derivative of e to the x is e to the x all day long, and 7 is just a multiplier. So this is just going to be 7e to the x. My last one is my regular power rule, and it is x raised to the negative 3. That negative 3 is going to come down as a multiplier, so it becomes a positive 3x. And then I subtract 1 from that exponent, so it is minus 4. And that's it. That's it. Now, I would have done D, but Max is like, no, I want to do that myself, so absolutely. All right, so on A, we're going to do the derivative of each piece individually because I have addition between them, so I'm going to do each term individually. So f prime of x is equal to, what's the derivative of x? 1. What's the derivative of e to the x? E to the x. All day long. So on B, f prime of x, what is the derivative of 5x to the 7th? 35x to the 6th. What is the derivative of negative 3e to the x? All day long. And then e to the third is a constant. So it's plus 0, or you don't even have to do that. E to the third is a constant. If that was e to the 3x, then I'd have to do something with it, but it's just a constant. So it's just e to the 3 is just a constant. On D, I'm going to have to do the chain rule here. So r prime, and I was so happy when I was going around because it looked like a number of you understood how to do that correctly. It's okay if you didn't, though. It's okay, you got time to practice. So the first thing I'm going to do is the cosine of e to the 3x cubed. So I can write this as the cosine of e to the 2x, the quantity cubed, if that helps me with the chain rule. So 3 is going to come down out front. And then it becomes the cosine, and I can write that as squared, or I can write it with the parentheses again with a squared on the outside. E to the 2x. Okay. Now I'm going to do the derivative of cosine, because I'm going to go in. So that was my most outer function. That is the derivative of my most outer function. Now I'm going to do the derivative of cosine. That is my next function in. And what is the derivative of cosine? So minus the sine, e to the 2x. Now I go in further, and I'm going to do the derivative of e to the x, because that's my angle, so I'm going to do the derivative of my angle. What is the derivative of e to the 2x? It is 2e to the 2x, because it is e to the 2x multiplied by the derivative of 2x, and that is my final answer. I'm just going to clean it up just a little bit. So I'm just going to write this as negative 6, because of 2, the 3 and the negative 1, so negative 6. I'm going to write e to the 2x first, and then I'm going to write it as the cosine squared of e to the 2x, the sine of e to the 2x. How
did you get 6e to negative 6e?
So I got the negative 6 from this number 3, this negative 1, and this 2. How was that? You're doing okay? Not too bad? Cool. So now we're going to look at the natural log derivative. So the natural log, we know that we can't put 0 into the natural log. But we do have to consider what happens when I have a negative x and just x. And the reason I say that is because I can take the natural log of a negative 3. So I do have to consider that when it is the natural log of a negative number, which ends up being the natural log of a positive number. That negative on the inside does a reflection across the y-axis. So I do have to consider that. So when I have x is greater than 0, I get this first one. When x is greater than 0, the derivative is just 1 over x. When x is less than 0, it is still just 1 over x. So what we get from this is that we get the natural log of x. The derivative of that is just 1 over x. Yes? So the reason I have to do the absolute value of this is because I can find this, right? I can find the natural log of a negative number because it's the negative of a negative. So I have to consider what's on the left side of my y-axis, and I have to consider what's on the right side of my y-axis. Well, we can as long as I'm not doing it at the corner. And the corner in this would have been 0, but it's not defined at 0 anyways. So I can do the derivative of the natural log of the absolute value of x is because I can't do the derivative at the corner, and the corner, if there was one, would have been at 0, but it's not defined there. So I kind of cheat. I can do the derivative of the absolute value all day long. However, I can't do it at the corner. I can't do it at the V shape. So I have to do the left side or the right side, which is why we break it apart. We broke this apart on the left side and the right side. So you can do the derivatives of absolute values. You just can't do it over its entire domain. You can't do it at the corner. Yes?
So if you see a negative x, just treat it like positive.
Yep. Yep. And that leads us to these. The derivative of the natural log of x is 1 over x. If you have a composition of functions, generically, if I'm doing the derivative du of the natural log of u, this is 1 over u multiplied by u prime. So I can do the chain rule on this. So I can do the natural log of the cosine of 2e to the x. How are we doing? Didn't it feel like snow this morning? Didn't it feel like snow? I feel like snow this morning to me too. And I thought there's a reason I moved from Colorado, because we don't get snow here really. I don't really like snow that much anymore. I used to like it. No, not a fan. How are we doing? Doing good. So the reason we go through all of this, if you all have looked at your quiz, on your quiz, I'm just going to kind of go down because it's going to get even better and better and so much better. The whole reason we spend the time doing this is because we see natural logs all the time, right? The other reason that we do this is because we end up with something like that.
Do we really though?
Yes, we do. And it really isn't difficult. It really is not difficult. We will when we get there, but right now we're not. We'll get there. We'll get there tomorrow. So there's one on your take-home quiz that's like this. So don't do this one the regular way. For the love of gophers, do not start doing the chain product rule kind of weirdness. Don't do it. Yes? Oh, no, because it's to the fourth powers and stuff, and they end up with square roots, and no. You love yourself, don't do it. Wait. No, wait. Just wait, trust me. Just stop. Exactly. Just because you can doesn't mean you should. Don't do it. Say no. Say no. Okay. Which one of these would you like me to do? C? D? D? Okay. So, to make my life easy, is I'm going to consider this u, right? So that if I'm doing the derivative of this, this is going to be 1 over u prime. If u is the function inside my natural log, then the first thing I'm going to do is find out what u prime is. So if u is equal to the cosine cubed of x, u prime must be what? 3 cosine 2x multiplied by what? Negative sine x, right? So it's just going to be equal to 3 cosine squared x negative sine x. Do you all agree to that? Yes.
Would it sign off with this one?
No, because it's the chain rule. It's the derivative of cosine, which is just negative sine. So this derivative, using the rule, is going to be 1 over the cosine cubed x, that's 1 over u. The derivative of u, which is negative 3 cosine squared x sine x, which is equal to my cosines will cancel. My cosines cancel. So I end up with negative 3 sine x over cosine x. My final answer is negative 3 the tangent x. And there's my final answer. You have to simplify. So it's not the calculus that it's going to mess you up, it's your simplifications that's going to mess you up. Again, what happened with this cosine and this cosine reduced? So the cosine squared goes into cosine squared once. It goes into the cosine cubed cosine times. So I just have,
I thought it was subtracting. It looks like a 1 out of
better?
Yeah, it was just.
Okay. So I end up with a negative 3 the tangent of x. How are we doing? Doing okay, a little shaky? It's okay if we're a little shaky. Go ahead and do those first 3 and then give you some time to go over them, and then I'll take just okay. All right, let's take a look at the first one. So I want to consider that as u. So u equals 3x. U prime is equal to 3. This should be 1 over u prime. So this is going to equal the d dx of the natural log of 3x. Should simply be 1 over 3x multiplied by 3. So my answer is just 1 over x. How was that? Cool. Then on this one, my u is 2x to the 8th. My u prime is going to be 16x to the 7th. So it means that is going to be equal to 1 over u so 1 over 2x to the 8th, multiplied by u prime, which is 16x to the 7th, which just gives me 8 over x. How are we doing? Not doing too bad, I hope.
This was the first one, but C threw me off.
Okay. So on C, we have one of two options. Option A is we multiply through and still do the product rule. Option B is we just do the product rule. What do you all want to do? Let's just do the product rule. So if I'm just going to do the product rule, I'm going to label this as u. So u is equal to x squared plus 1. U prime is going to be 2x. Then I'm going to label this v. So v is equal to the natural log of x to the third. V prime is going to be 1 over x to the third, multiplied by the derivative of x to the third, so that is 3x squared. So in other words, I get 3 over x. So now I'm going to use the product rule. And the product rule should be, if I have u v prime, this should equal u prime v plus v prime u. So this is equal to 2x multiplied by the natural log of x to the third, and then plus 3 over x multiplied by x squared plus 1. Yes?
Forget, does it matter which side those terms run with the plus sign? Just
No.
once they're together.
Multiplication is associative and commutative, so it doesn't matter. Now, if you wanted to get all fancy and clean this up, you'd make it all over x. And personally, I probably wouldn't, especially if I have to do the second derivative. I probably would not clean this up by writing everything all over x. I'd leave it as is, especially if I have to do the second derivative. But if you're like, man, I really love my algebra, then you can absolutely clean this up by multiplying the first term by x. And so if you could write this as 2x squared, the natural log of x cubed, plus 3 x squared plus 1 all over x. It didn't really gain us much. I can't combine like terms. It didn't gain me anything. But if you're like, yeah, I love algebra. Cool. There you go. I won't stop you. I won't stop your love of algebra. All right. So here is my last one. Here is E. I would recommend the product rule. So if I were to do E, what I would do is I'd just rewrite this as d dx of x raised to the negative 3 multiplied by the natural log of x squared, so that I can use it as the product rule versus the quotient rule. That's just me. You all can choose the quotient rule if you're like, I love it. Cool. I won't stop you. So if you did the product rule, this is how it would look. If you did the quotient rule, we should still get the same answer. I'm going to do the product rule. That means u will be x to the negative 3. U prime will be negative 3x to the negative 4. I'm going to say v is equal to the natural log of x squared. V prime is going to be 1 over x squared, the derivative of x squared. So it's just 2 over x. Now I'm going to go ahead and use the product rule, which says it'll be the derivative of my first one, which is negative 3x to the negative 4, multiplied by my second one, which is the natural log of x squared. And then it's going to be plus the derivative of my second one, which is just 2 over x, multiplied by the derivative, or the first one, so it's x to the negative 3. And the only thing you have to do is you do have to clean up that second term. You don't have to put it all under the same. It will end up being all over x to the 4th. But you do have to clean up this part. This is the only part that you have to clean up. You can't leave that. So this is equal to negative 3x to the negative 4, the natural log of x squared, plus 2x to the negative 4. That's one way to write it. That's totally good way to write it. Because they're both over x to the 4th, you can write it as this way as well, as negative 3, the natural log of x squared, plus 2 all over x to the fourth. They're both over x to the fourth because they're both x raised to the negative 4. Yes. If I had to do the second derivative, I would probably leave it like this to use it as a second derivative. I probably would do it that way myself. If it doesn't allow you to put in negative exponents, then you will have to go and do it and simplify it that way. If it doesn't allow negative exponents, you'll have to do it that way. How are we doing so far? Not too bad? Okay, cool. I'm actually going to let you out just like 1 minute early, so use that minute wisely. We're going to have a quiz.